Hello. So in this video, we are going to extend your knowledge of linear equations. Now that you've had a little bit of practice on how we write those equations and how we graph them, we're going to extend that knowledge and do an application problem in this video. Before we get there, I just wanted to review some information that you had in worksheet 13 and also on your graphing summary sheet. So if we take a closer look here at some of these comments here on the part 2, we remember that when we're using the slope-intercept form, in order to write an equation, all we really need is finding m, the slope, and b, which is the y-intercept, where that line crosses the y-axis. So we're going to be using that knowledge today. Now, of course, we're going to be writing the equation and graphing. So when we're looking at writing the equation, remember that we have 3 different scenarios. One, they actually give us the graph, and we can write the equation from that. Secondly, they're going to give us the slope. They'll give us our m, and they give us 1 point. And, of course, we already have m, so if we have a point, we can plug in that point and we can solve for b. So we'll be able to find our y-intercept, and then we'll have our m and we'll have our b. And lastly, sometimes we're just given 2 points. Okay, and so what that means is that we use the 2 points to find our m using our formula, this formula right here, right? Our change in our y coordinates divided by our change in our x coordinates. We find our m. And then we just plug in one of the given points. I know they give us 2, but we only need 1, and then we can solve for b. So those are your 3 scenarios that you're given, and usually in an application problem, you are going to be dealing with the second and third option. Okay, so I'd like to jump to a problem in your worksheet. We're going to look at problem number 32. This is a very important problem, and you will see a problem like it coming up on your final exam. So that's why I think it's pretty important to cover this. All right. So the number of students who completed high school and enrolled in college that same year increased from 1.8 million in 2005 to 2.1 million in 2009. Assume this data is linear. Okay, so if you think about the 3 options that we just talked about, obviously they're not giving us the graph. We know in A, we can see right here, we're going to have to write an equation. And of course we need that equation before we can even graph. So we're going to look at the given information above, and they're either going to give us the slope and 1 point, or they're going to give us 2 points. And we can see here that they tie this information together, 1.8 million students in 2005 and 2.1 million in 2009. So that's starting to look like we have 2 points that are given. Let's jump down to A and read what it says here. So find the equation for the line, including the given data points. Let x represent the number of years after 2000 and y the number of recent high school graduates who enrolled in college that year. Okay, so this is kind of nice because it helps us right off the bat to know what x and y should be. And I'm going to really make a exaggerated highlight there for the word after. X represents the number of years after 2000. Okay, and y is going to be the number of graduates in millions. All right, so let's go back up here and take a look at our information that's given and see if we can pull out what our points might be. So we need to use those 2 points to find our m and to find our b. All right, so we know that in 2005, we know that that is 5 years after 2000, right? So if x represents the years after 2000, one of our points would start with 5, and in that year there was 1.8 million graduates, because we know that y represents the number of graduates, right? That's our y, our years is our x. All right, for our second point, 2009, that is 9 years after 2000. So our second point would be 9 and 2.1. Okay, so we've pulled our 2 points now from the scenario, and now we need to think about, okay, how do we find those 2 pieces of information to plug into our point slope. Our slope intercept equation right there. We've got to find our m, got to find our b. Remember that the x and y represent an infinite number of points on that line. So those never change. We always have the y and the x in the final equation that we're creating. All right, so let's find our m. Okay, so m is going to be the change in our y coordinates and divided by the change in our x coordinates. That is the formula that we use to find our slope here. So this is the first. So we're going to find m first. Okay. And it doesn't really matter what point you pick to be your first and your second. As long as you're consistent, it doesn't really matter. I'm just going to randomly say, label those first point, second point. All right, so I'm going to start with my second y coordinate, which is 2.1, and I'm going to subtract from that my first y coordinate, which is 1.8. Since I started with the second y, I have to start with the second x value. Okay, and this is going to give me 0.3 over 4. Now, that's not a nice round number. Is not an integer, and I want you guys to know that that's okay. A lot of times in our application problems, we're not going to have a nice, rounded number to work with, and that's okay. I want you to feel comfortable with that. However, if you leave a decimal in your slope, it's going to be a little bit harder to work with. So I would suggest to just go ahead and take your calculator, take 0.3 divided by 4. That's going to give you a 0.075. 0.075 is our slope. Now, sometimes you guys will have a decimal that goes out quite a ways, and you can round it. I wouldn't round it any less than 2 or 3 digits for sure, because you want to try to be as exact as possible. All right, so we just found our m, and now we need to find our b. And remember, when we're looking for our b, we're just plugging in a point. So we just want to plug 1 point. We're given 2, so we can choose which one. Both of the points are on that line, so it doesn't really matter which one we choose. Okay, so let's do that. I'm going to take my original y is equal to, we already know 0.075 is our slope, so I can stick that in there. X plus b. Remember, we're trying to find b, so we need to plug in the value for our x and our y. So I'm just going to pick this first point here just because the numbers are a teeny bit lower. Doesn't really matter. You guys will actually have the same answer for b if you plugged in the other point. 0.075 for our slope plus b. All right, and now just to save us a little bit of time, I've already done the math. You guys will want to do that just to double check everything, but I get 1.425 for my b. And then this is all the work, and what we're doing is we're just taking this work that we've done and we just plug in the values that we found. Oopsie, that is not right. We need a 0.075 x plus 1.425. So this is the equation that represents the given situation. Now, of course, that's really important to find at the beginning because everything that we graph is based on this equation, right? All right, let's jump down to B. It says graph the linear equation on the graph below with proper scale. Let me do a little bit of highlighting here. We got to find some important things. We need the proper scale, and we need labels on that graph. And then we also want to plot and label the given points. Okay, so we want to make sure, because all of that, the scaling, the labeling, plotting, all of that will constitute the points, the total point value for these type of problems. And if you leave that out, of course, you miss some of those points. Now, we have to scale this graph, right? We need to figure out, what are my numbers going to be basically from here to here or here to here? Which axis is my x, which is my y, that sort of thing. I got to figure out what distance I want between all of these. This is the decisions that we have to make, and that information is based on what we have in front of us. It's going to change depending on the problem that we're working on. We always know that our x, or our independent variable, is on our horizontal axis. We also know that it is something that we know that doesn't change. It doesn't depend on anything else. So it changes kind of on its own. And we know that time is always independent. It marches on. So we can just go ahead and label this axis. We know that x represents number of years since 2000. Our y is always our vertical axis. And we already know that this represents the number of grads, of high school grads. And we try to put our units in. We know this is in millions, which is helpful because we don't want to have to put all those zeros in when we're trying to graph. That would be very difficult. Okay, guys, now from this point, we need to kind of figure out, how we're going to scale and what dimension to use on our graph. You guys have some choices here. I would actually recommend that you set up a t-table. It doesn't ask you to do this, but I find this very helpful. And put in your points that you have. Okay, so we know that in the year 2005, we had 1.8 million. We know in the year 2009, 2.1 million. And then I would always just look ahead, because a lot of times they're going to have you extend your knowledge of your graph, or do some estimating of other totals based on the graph that you have done. A lot of times I like to incorporate those into my decision making because it helps me to know what my high and low numbers need to be. So in C, it asks us to estimate the number of high school grads who enrolled in college in 2007 and in 2015. And then it wants us to check using our equations. We're going to estimate and then we're going to check. Well, you can actually do that in the other way around if you'd like to. We know that in the year 2007, x is going to equal 7. And in the year 2015, x is going to equal 15. If we want to fill in these totals right here and right here, and so that we can use this information in our graph when we're scaling, we can just go ahead and skip down to C and do that math and then come back. That's okay. All right. So let's go ahead and in 2007, we'll use our equation, 0.075 times 7, right? Plus 1.425. Now, of course, you guys would do the math. You would double check everything. I'm going to try to save some time in the video here. Okay, so y is equal to 1.95 million students in 2007. So my coordinate would be 7, 1.95. Cool. So we come back up here, and that actually fits in there nicely. It looks like we did the math correct because it is right between 1.8 and 2.1. All right, now let's check out 2015. 425. Sorry about that. All right, and when we do that math, we're going to get y is equal to 2.55. So that means in the year 2015, we have 2.55 million graduates. So we can come up here and we can plug that in. Now this is helpful, like I said, because we want to know how we can scale our graph. Now if you count all the little scale marks here, we can see this is a 15 by 15 grid. So if we start here on our x-axis, we can see that our low number is 5, our high number is 15. We want to try to go as small of a scale as possible because it's a lot easier to graph if there's, the smallest distance possible between those hash marks. Basically, we're going to be able to see our graph better. We're going to be able to graph and plot our points better. So since I have 15 spaces here, I will go back to black, start at 0, and 1, 2, 3, 4, 5. You do not have to put every single number on there if you don't want to. 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, excuse me. So on our y-axis, let's take a look at that. You can see we start here at 1.8, and it only goes up to 2.55. So we definitely don't need to go from 0 to 15. We can go a lot smaller than that. And, there's really no right or wrong here. I would definitely try to go as small as possible. But, pick some numbers, pick some decimals in there that are nice and round. Like, for example, you wouldn't want to go by 0.3s or 0.4s or something like that, 0.8s. It's a little bit harder for you to do your graphing, but you could go by 0.25 or 0.2. Let's see, by 0.2, we've got 5 0.2s basically between 1 and 3. Well, that would give us our 15 here if we were to do it that way. So I think for me that feels like a safe way to do it. You could go by 0.25s as well if you wanted to. Okay, let's do 0.2s though. So we've got 0.2, 4, 6, 8. This would be 1. I should have used my black. Sorry about that, guys. 1. And then we've got 0.2, 4, 6, 8. Whoopsie. This would be 2, 2, 4, 6, 8, and 3. Perfect. All right, I think we're set. Let's go ahead and plot our points. And of course, the other nice thing about having a t-table is you can see if we were to put parentheses around here, these are our points, right? We're just plotting these guys. So 5 and 1.8, 5, 1, 2, 4, 6, 8. I think I will use a different color for my points. So 5. All right, let's go with 7 and 1.95. Here's my 7. Here's my 1.8 and my 2. So it's a little above halfway. Definitely having to do some estimating, aren't we? 9. Here's my 9. We're going to go to 2.1, which is halfway between 2.0 and 2.2. And we go to 15, and we're going to go to 2.2, 4, a little teeny bit above halfway. The other thing that I like to do, guys, is I know we could have done it at the beginning, but I like to figure out what my x-intercept is. And we know from the equation, if we go back to this equation, if I were to stick 0 in here, we know that this is my y-intercept. We also know that because this is b, right? And b is my y-intercept. So we're going to go 1.425 here. And so we can go 1.24. That's a 6. So it's going to probably be right about there. And I don't have a straight edge, so mine might be off just a teeny bit, but you can see for the most part these points are right in line with each other, which is kind of nice. We also want to make sure that we're labeling these points, right? So we can go back. This is my 0, 1.425. Go here, we're going to say this is our 5 and our 1.8 and 7, 1.95, 9, 2.1, and 15, 2.55. Whoopsie, 2.55. There we go. All right, so if we look back at our graph, we can see that everything is labeled. We've got our points are nice, make a nice straight line, which is what we are expecting to happen. And of course, if you had done C at the end, you would have gone and you would have done some estimating. You would have gone up here at your x is equal to 7, and you probably would have said, well, I don't know, at 2007 it's almost 2 million, which is about what we get, 1.95, and in 2015 it's about 0.5 million, 2.5 million, which is about what we got. So it's up to you kind of how you want to do that. I just recommend the T-table because it is very valuable to figuring out kind of your scaling and your dimensions. Okay guys, like I said, this is a very important problem, and I would recommend that you guys practice this. Don't be afraid of them. Just do one after the other, and you'll start to get into a rhythm with these and realize that you really do the same thing. You're just kind of looking at the information that's given, making a decision as to, okay, are they giving me 2 points? And if they are, I'm going to find my M and my B. Sometimes they actually give you the slope. Sometimes they'll say the rate of change is ... Well, rate of change means slope. So you can look for that as well. All right, guys, thanks. We'll talk to you soon.